Hai, Assalamualaikum. Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad LUTFI bin Muhammad SHAHRUL MUNIR, and my matrix number is 200460, and I'm from group 2. Gonna be presenting on the project for the OJS subjects, and also my group mates, which is Olivia, JANAM dan LALO, matrix number is 202691, and NURBALQIS binti ZULKEFLI 202471, and RABIAHTUL AISHAH binti ZULKEFLI 203720. Right, so for the content of the presentation, we already separated. So I'm gonna give the introduction about the project, and also Olivia and Balkis will do the methodology and result, and for the Aisha, I'm gonna explain about the discussion on this project. Right, so without further ado, we go to the introduction of the projects. Right, as we all know, by this project we get to use the ArcGIS, and also we know a bit more about the GIS systems, right? So what is GIS basically? So GIS is a computer-based systems that allow the user to questions and manipulate various layer of spatial data, right? So for the what is mean by the spatial, right? So spatial mean related to space, and data means facts or statistics collected together for reference or analysis. So both combined together, it makes the space data, right? Something like that. So when was the GIS originated? So it is originated in 1960s, as you can see, with computer and early conceptions of quantitative and computational geography. So Roger Tomlinson's vision culminated in the creation of the world's first computerized GIS in 1963. Through his planning, initiating and implementing of the Canada Geographic Information System. So it is based on the Canada Geographic Information System that makes the GIS. So who are using the GIS? Who are using the GIS? It is used by a whole host of academic institutions, and also used by several government and private organizations around the world that want to use the GIS about the spatial data. So there are many, but it is not so publicly access to all. Not everyone can publicly access to all of the spatial data, right? So next one is how it works. So the ArcMaps, which is one of the software in the primary software in the ArcGIS, used to display and explore GIS data for the study region, and to build map layout for printing or publication based on those symbols. So by using the ArcMap, we can plot, or we can use the tools that have software for us to build the map or printing or publication based publication, right? So I think that's a little bit about the introduction on the GIS, and also the ArcGIS and the ArcMap. All right, I pass to the next presenter, which is Olivia. All right, thank you.
Thank you, Luffy, for the explanation of the introduction. I am Olivia JANAM DANI LALO with metric number 202691. We'll continue with methodology and the result that we will get for each step. So first of all, we need to find the after storm imagery from the folder that are given to us. So when we insert it into the ArcGIS, we will get this. This is the imagery that we will get. And then next, same as after storm, we also need to find the before storm imagery from the pre-image folder. So when we insert it into the ArcGIS, so this is what we will get. Next, okay, so we need to create shapefile that contain points and use before storm imagery to put a point on each house. So what does it mean? So first of all, we need to create the shapefile and then we rename it as a houses_2. And then this is the point that we will use to point each house. Next, so we will use, okay, actually we supposed to use the before storm imagery. So this is shown for point in each location of the house. And then this is for after storm imagery. This is the point that shows location of house of each houses. So to do this, we need to edit, and then we need to point it one by one for each houses. So next, so we will use after storm imagery to record appearance changes to the house in attribute table on scale 1 to 10. All right, so to do this, first of all, we need to open the attribute table. So this is the attribute table of the houses_2. And then we need to add one field, which is renamed as a app_damage. All right, and then we need to scale it. Okay, to scale it, we need to refer from here. So we're supposed to zoom it for easier for us to do the scale of the description of each houses. All right, so for 10, actually for 10 is when the house is destroyed or gone, when we didn't see the house on the imagery. And then for 0, so here, so for 0, it is when the house is no damage at all. And then for 1 to 9, it is a scale. It is scale of apparent and visible damage. So this is the scale that we get when we zoom into the after storm imagery. All right. So next. All right. So there's another way to detect damage by using parcel dataset. Okay, for before, we got the damage of each house is by scaling from each house. Okay, so for this, we use a parcel dataset. So here, we need to use parcel_2008 and parcel for 2009. All right. So we need to insert both parcel, which is parcel 2008 and 2009 into our ArcGIS, and then we need to check the attribute table. Okay. All right. This is the attribute table for 2008. Okay, so for 2008, so here we can see that actually for this is the value. This is the value of the land in 2008. This is value of 2008 for improvement of house. And then this is value of 2008 for the total. So same goes with attribute table for 2009. So this is value of 2009 of land. This is the value of the improvement, and this is the total value in 2009. Okay, next. When we insert both parcel 2008 and 2009, we will join it. We will join the value from each two parcel file. So this is how we join it. So this is, we will join data from another layer based on spatial location, and then we will choose parcel 2008, and then we will click OK. And then same goes with parcel 2009, we will click OK. So, all right. So actually this is when we didn't join it for 2008, parcel 2008. And then this is for parcel 2009. So when we join both, this is what we will get. Okay. All right, next. Okay, for next, we need to find the distance to the shore for each house. So to get the distance to the shore, we need to create a new vector file offline, which is renamed as a shoreline, and using projection not 1983 UTM zone 15N. Okay, next. Okay, this is the line that we create. We need to edit, same as we edit for point for each house. So same goes with this. We need to edit, and then we need to use line. So this is the shoreline from here to here. Okay, and then next we will create a file using Notepad, and then we rename it as a storm underscore center. So for this, we will use X, Y coordinate that are given to us. So this is the coordinate. And then this is where we add it into the GIS. Okay, next. Okay. Sorry. So this is when we add the XY data in our ArcGIS, we need to display the XY point, and then we export it into the permanent file, and then we will rename it as a IKE underscore center. So this is when we rename it. Okay, when we use the projection, when we project the coordinate, this coordinate, this is what we will get. This is the coordinate of the of this. So that's all from me. I will pass the next session to Balkis to continue. Thank you.
Okay, thanks to Olivia. I will continue for method and result. So after add X and Y data, we must find the distance from every house to the storm center and put in the field called as distance underscore center. So we will find this from attribute table. Next. After that, we must find the percent cover of each land use land cover that call LULC type fall within 10 meter and 50 meter. So we must name this buff underscore 10 for buffer house by 10 meter and buff underscore 50 for buffer house by 50 meter. Next. So this is the image for before storm. So this is the buffer for 10M and 50M. So we can see the before storm imagery. Next, this is the after storm imagery. So this is the buffer for 10 meter and 50 meter. Next, we look at the LULC underscore final raster file and not the metadata. Then we convert the LULC underscore final layer into vector, which is vectorized underscore LULC. So this is before we convert, and after we convert, this will be appear at the arch map. Next. So before we adding the value, we must reproject the vectorized underscore LULC to fit the same projection. So we call the vectorized underscore LULC underscore reproject. Then same. So this is the same for both 10M and 50M. So this is the final loop. Next, after adding value, we must make sure the value field as grade code and add value. So this will visualize the LULC various colors. So this will be same for both 10M and 50M. So we can see the different before and after adding value. Next, so before adding value, we must intersect vectorize underscore LULC underscore reproject with buff10 become LULC underscore buff10 underscore intercept, same as the 50 meter, same as the buff 50 meter. So the above is 10M and this is 50M. Next, after we adding the value, the intersect vectorize underscore LULC underscore reproj with buff 10 become LULC underscore buff 10 underscore intercept. So above is 10M and below is 50M. So we can see the difference before and after adding value. Okay, next. Okay, this is the attribute table that we can find from LULC values surrounding house and coordinate with FID numbers within attributes tables. So next, so this is the area buff for 50 meter. So this is, we can see from attribute table also. Then we can calculate the area for each polygon, which is we can name as LULC underscore buffer underscore 50 and underscore area. Next, after that, we must find the elevation value for the top of each house, which is LIDAR. So we must find the data in LIDAR folder. Next, okay, this is the LIDAR data from LIDAR folder. So above is input data and below is output data. So the LIDAR data, we must use C, D, and B. Next. So after we put the LIDAR CDB to the arch map, so the LIDAR data should look black or white or grayscale. So this is the example. This is the example for LIDAR B, LIDAR D, and LIDAR C. Next. Okay, this is the result for LIDAR C. And this is the result for LIDAR D. And this is the result for LIDAR B. So this is the result for full LIDAR CDB. Next. Okay, we must find the pixel value. So we can find the pixel value from identify tool. So the value from the top of the house in LiDAR imagery, then the elevation value called as pixel value. Okay, this is the example that we can find the pixel value. Next. So this is our data of project that consists of FID, app damage, and near distance. This is the example. Okay. And okay, this is our graph for amount of housing damage against independence factors. And the graph is house damage vs distance to show. So we can see the data, so many data we get. So that's all from me. I will pass to the next presenter, Aisha.
All right, thank you, Balkis, for a great explanation. Hi, my name is Aisha. I will continue this presentation with discussion. Firstly, I will talk about the advantages and disadvantages of ArcGIS. All right, the advantages of ArcGIS is the capability it provides for geographical analysis and data is well likely by most users. In the current edition, there have been a few enhancements. The most popular Python data analysis library are included in the most recent version. In addition, the software comes with a series of tools. User says that ArcGIS is a highly strong tool that comes with a variety of capabilities. Next, handling a big amount of vector data efficiently. A significant amount of vector and raster data will be handled accurately and effectively by the programs. This is another thing that make this software merely the best. All right. Then the disadvantages of ArcGIS. ArcGIS is the cost of ArcGIS is prohibitively high. The standard license are prohibitively expensive. Furthermore, it is not an open source. As a result, it is not widely used in the academics. Moreover, AHMAD user interface is not particularly appealing, which are not user-friendly. It is not easy to notice all the details. All right. Next, I will talk about the factor that contribute to hurricane. There are three factors that contribute to hurricane. Firstly is the warm sea surface temperature. All right. This is an important component because it serves as a fuel source for hurricane. To develop into a tropical storm or hurricane, sea surface temperature must be at least 80 degrees Fahrenheit, which are 27 degrees Celsius, where the system is located. All right, next, the light wind aloft, because hurricane and tropical storm move from east to west. There are aided by an easterly wind flow. There are also vertical system because thunderstorm form vertically in the atmosphere. These two conditions distinguish hurricane from the storm that normally bring us our weather and make it critical to have light westerly wind aloft to prevent shearing or tearing apart of the thunderstorm. All right, lastly is the rotation or the spin. To be classified as a depression, storm, or hurricane, the wave must have some rotation or spin generated by the wind that come together to form it. Without it, the wave is simply another area of low pressure. All right. Next. Lastly, I will discuss about the factor that affect the house damage. There are two factors that will affect the house damage, which are independent and secondly dependent factor. All right. The independent factor are distance to shore, and then secondly distance storm ice landfall location. Then the dependent factor that contribute to hurricane are firstly house damage on a scale 1 to 10, then house damage present in dollar or by visual appearance. All right, I think that's all from us. Thank you.